Hello everyone, welcome to ELO YouTube channel where we discuss organic chemistry in simple terms. Please do not forget to share, subscribe and like my channel, and thank you for your support so far. Today we'll be discussing alkanes and their nomenclatures. Before we proceed to alkanes and their nomenclatures, let us consider some important characteristics of alkanes. Alkanes are saturated hydrocarbon with the general formula of CnH2n plus 2. From the general formula, the first member is gotten if you substitute the carbon atom to be equals to 1, then you will get the general formula of CH4, which is equals to methane, meaning that methane is the first member of the alkane family. The second member is, if you follow the same trend, the second member is C2H6, which corresponds to ethane. If you follow the same formula, you will get the second member to have the molecular formula of C2H6, which is ethane. Then the third member is C3H8, which is propane. The fourth member is C4H10, which is butane. So generally, if you substitute the number of carbon equals to 5 down to 10, you will get the corresponding pentane for 5 member, hexane for 6 member, heptane for 7th member, octane for 8th member, nonane for 9th member, and decane for 10th member. So all these corresponds to the homologous series of the alkane family. Another important information we can derive from this homologous series is from the first member, which is the methane with the molecular formula of CH4, to the fourth member, which is butane with the molecular formula of C4H10, are gases, while higher number from the C5 down are liquids. Another important characteristic of alkane is alkanes are sp3 hybridized, which is a characteristic of single bond. Using methane, for example, they have the bond angle of 109 degrees. Having discussed some important characteristics of alkanes, let's now consider the nomenclatures of alkane. Before we proceed to the nomenclatures of alkane, let us discuss an important theme which will enable us to proceed to the nomenclature of alkane. That important term is the alkyl group. The alkyl groups are referred to as substituents in the parent chain, which is the alkane. They are formed from alkane when an alkane loses one hydrogen, and they are named by replacing the suffix ane in alkane with yl. From this, it means that they have the general formula of CnH2n plus 1 since they are formed from alkane. Let us now consider from the table below how alkyl groups are formed from alkane. Using methane, for example, which has the general formula of CH4, when methane loses one hydrogen, we have the methyl group which has the formula of CH3. Similarly, ethane has the molecular formula of C2H6. When it loses one hydrogen, it forms ethyl, which has the formula of C2H5. In the same vein, propane has the molecular formula of C3H8. When propane loses one hydrogen, it forms a propyl group, which has the molecular formula of C3H7. So, having considered the characteristics of alkanes and also the important term, which is the alkyl group, let us now proceed to rules in naming alkanes. The first rule in naming alkane is to identify the parent chain. The parent chain is the longest chain, and any carbon or group outside the parent chain is considered as a substituent or branch. Having identified the parent chain, the next rule is how to number the parent chain. The parent chain is numbered starting from the carbon atom closest to the substituent. Let us consider these two structures below. Using these two compounds as an example, compound A and compound B are identical compounds with different numberings. As earlier stated, the first thing to do is to identify the parent chain, and the parent chain is the longest chain. In these two compounds, the longest chain is the chain that contains 5 carbon atoms. That is the first thing to do. Then the second step is to number the parent chain. There are two ways I can number this parent chain. I can start from this first carbon here, 1, 2, 3, 4, 5, and I can start from the first carbon in the left hand side from compound B. That is 1, 2, 3, 4. Here now, they are the same compound but with different numberings. In this numbering, the numbering of A is correct because A gives the substituent position 2. The substituent is any chain outside the longest chain or any chain outside the parent chain. In A, the substituent has position 2, but in B, the substituent has position 4. Therefore, the correct name of this compound is 2-methylpentane and not 4-methylpentane. One important thing we have to note here is, in naming an organic compound, one must start with the substituent and end the name with the parent compound. That is why I started with the substituent, which is 2-methyl. It is 2 because the position of the substituent is at carbon number 2 in the parent compound. And I ended the compound with the parent compound, which is pentane. And pentane is the main chain, while 2-methyl is regarded as the substituent or branch. The third rule in naming alkane is, when there are more than one alkyl substituent in the parent chain, the alkyl substituents are arranged in an alphabetical order. Let us consider the example below. Here, the first thing I did was to identify my parent chain. As soon as I identify my parent chain, I will circle the compound so that I can identify the substituent and also the position of the substituent in the parent chain. After that, I will number the parent chain starting from the carbon atom that is closer to the branch. Having numbered the parent chain, from this compound below, I can see that I have two substituents at position 3 and position 4. And one of the substituents at position 3 is the methyl group, and the substituent in position 4 is the ethyl group. If you check between E and M, you will notice that alphabet E comes before alphabet M. Therefore, the correct name of this compound is 4-ethyl because E comes before M. 3-methyl because we have methyl group at position 3 in the parent chain. Then heptane, and heptane is the parent compound. This is in agreement with what I said earlier, that in naming a compound, the substituent has to come first, arranged in alphabetical order. Then the parent name ends the compound, and the parent chain is heptane because it's an alkane with 7 number of carbons. For rule number 4, when there are more than one identical alkyl substituent, we use di, tri, and tetra to indicate the number of identical substituents we have in the parent chain. Let us consider the example below. According to the rule, the first thing I have to do is to identify my parent chain. This is my parent chain. The next step is to number the parent chain, starting from the carbon atom closer to the branch. Having numbered the parent chain, you will observe that we have 3 identical substituents at position 2 and 4 of the parent chain. Therefore, in naming this compound, we have to take cognizance of the position of this substituent in the parent chain by using the prefixes di, tri, and tetra before adding the position of the substituent. Therefore, the correct name of this compound is 2,2,4-trimethylhexane. It is 2,2,4-trimethyl because we have 3 methyl substituents at position 2 and position 4 of the parent chain. Let us consider another example. The first thing to do is to identify the parent chain, which is the longest chain. Having identified the parent chain, the next thing is to number the parent chain starting from the carbon atom that is closer to the substituent. So having numbered the parent chain, we will observe that we have 2 identical substituents, which are the methyl substituents at position 3 of the parent chain. Therefore, the name of this compound is 3,3-dimethylpentane because we have two methyl substituents at position 3 of the parent chain. For halogenoalkanes, that is, alkanes that contain halogen as a substituent, we use the prefixes chloro when we have chlorine substituent, bromo when we have the substituent containing bromine, iodo when the substituent contains iodine, and fluoro when the substituent contains fluorine group. Also, when there are more than one halogen in the parent chain or the parent compound, we use the prefixes di, tri, and tetra to denote the number of halogen we have in the parent compound, and these halogens must be arranged in an alphabetical order. Let us use these two compounds below for example. Compound C and D are identical compounds, but what will account for the major difference between compound C and D is their method of numbering. Here, we have different position of substituents, which are the halogens in the carbon. So we are going to number this compound differently. From there, we can now identify the right numbering of these compounds. The first thing we have to check is the sum of positions of the substituent. The structure that has the least sum of substituents is the correct numbering. In compound C, 2 plus 2 plus 4, which are the positions of the substituent in the parent chain, will give me the total sum of 8. But in compound D, which is 4 plus 4 plus 2, will give me the total sum of the substituent to be 10. Therefore, the correct nomenclature of this compound is 2,2-dibromo 4-iodopentane. Compound C is named as 2,2-dibromo because we have two bromine atoms in position 2 of the parent chain, and B comes before I. That is why the halogen bromine comes first before the iodine. 4-iodopentane, the iodine substituent, is at position 4 of the parent chain. For cycloalkanes, groups outside the dicyclic compound is treated as a substituent, while the cyclic compound is regarded as the parent chain. Let us consider the examples below. The name of this compound, compound E, is bromocyclohexane. It is bromocyclohexane and not one bromocyclohexane because regardless of the position you put the bromine in the cyclic compound, it is still one. So the correct name of this compound is bromocyclohexane. The bromo is the substituent, while the parent chain or the parent compound is the cyclohexane. For compound F, the parent chain is still the cyclohexane, but the question there is, do we start numbering from the methyl group or from the ethyl groups? Here, ethyl has a higher carbon than methyl. Therefore, in numbering the compound, the position of ethyl group should take primacy over the methyl group. Therefore, the correct name of this compound F is 1-ethyl because the ethyl group is in position 1, 4-methyl because the methyl substituent is in position 4 of the parent chain. Then the main compound is the cyclohexane. Compounds G and H are identical compounds. What will differentiate between compounds G and H will be their method of numbering. In compound G, the parent chain is numbered in a clockwise direction, whereas in compound H, the parent chain is numbered in an anti-clockwise direction. So let us consider the sum of the position of the substituents. The one with the lower sum of substituents will be the right position of the substituent in the parent chain. In compound G, in the numbering, the substituent chlorine is in 1 and 3 position, and sum of 1 and 3 will give me 4. But in compound H, the position of the substituent is 1 and 4, and 1 plus 4 will give me 5. Therefore, compound G is the right way to number this compound. Therefore, the correct nomenclature of compound G is 1,3-dichlorocyclopentane. Thank you for listening to my video. Please like, subscribe and share. If you have any question, any concern, please leave your thoughts in the comment section. Thank you.